Distinguished business partners, distinguished audience, welcome to our event. As Çimsa, founded in Mersin in 1972, we are one of the leading cement and ready-mixed concrete producers in Turkey and world. And starting white cement production in 1990, we have exported white cement more than 65 countries with our integrated factories in Mersin, Eskişehir, and Valencia, Bunel, and our grinding plant in Houston and Texas. R&D in cement and building materials sector of our center in Formulane is giving customer technical support and product development activities, and we offer value-added solutions to our existing and potential customers. Today at the Çimsa Precast Seminar, together with you, our business partners and expert speakers, we will discuss the trends, dynamics, and new applications that shed light on the future of the sector. Our program will last about 3 hours, and today we will be able to listen the presentations of Professor Dr. Serkan Subaşı from Düzce University, Associate Professor Dr. Zeynep Başaran-Bundur from Özyeğin University, from Sparta University, from the Applied Sciences Department, Metin Davraz, and Professor Dr. Mustafa Şahmaran from Hacettepe University, and from Çimsa Ar-Ge team, Dr. Ayten Çabuçu will be making presentations. The questions that you will ask during the presentations can be addressed from the chat box. We hope that it will be a pleasant and a fruitful event for all of us. And the first topic of our program will be presented by Professor Dr. Serkan Subaşı from Düzce University. Glass fiber reinforced concrete and precast facade applications. Welcome. I think you can see my presentation right now. Hello, everyone. First of all, I would like to say welcome to each of the participants. And within the framework of this seminar, I'm going to present you the glass fiber reinforced concrete. Let me start my presentation. When we look at the content, I'm going to speak about the concrete and its components, and of course, the fiber concrete structures and CTBs, GRCs, and advantages. And of course, the concrete production features and advantages, and also the molding and production and related design criteria, and CTB and GRC type of facade applications and mounting details, panelization, also the precast facade, and practicing examples will be shared with you. When we look at the components, the concrete in itself basically is composed of aggregated sand and cement and water, and it has got a plastic form in its fluid form in the beginning, and it is one of the major popular products in construction. It's not composed of actually these three components. There are different types of polymeric contents and some chemical contents, and also some additives or fiber type of supplementary materials. And in the architectural designs, some color pigments are also being added. And when we look at those components, a few of them or all of them do have some certain amounts which are brought together, and the design of the concrete is being actually diversified according to these different type of contents. And when we look at the fiber concrete structures, of course, they do have a different resistance capacity, deformation capacity, and yielding capacity. And when we compare and contrast, it has got some, of course, important features. And in order to enhance and empower the structure and make it more resistant in different parameters, of course, there are different types of additives and polymeric or mineral type of natural organic fiber sources are being added in the content, and low amount of and very homogeneous fiber structures are also providing an opportunity for the shearing capacity and increasing the level of resistance and bringing a better outcome in appearance. And of course, when we look at the fiber structures, in order to enhance and empower, the structure of concretes are all being used. Without looking at the fiber type, what is important is the homogeneous distribution of the fibers. And of course, the homogeneous structure should not be distracted. This is a very important feature. Both in the production phase, the mixing process should be taken into account very seriously, and also the molded concrete, and also the preservation and production and the equal distribution of the fibers are essential to be composed. And if you manage to do that, the contribution of the fibers inside the concrete will be very high in power. And there are different matrices, concrete matrices, and also interaction factors. And when the matrix of the fibers are hard, it is going to provide a higher elasticity. And of course, it is going to be in the connection of fiber and matrix in an adjacent way. And of course, the geometry of the fiber is very important, and the length of the fiber should be efficient and sufficient enough. And also the fiber type, like steel, polymers, and also mineral and natural fibers should be applicable. And of course, the type of the fiber should be in compliance with the used concrete structure. And of course, it should be guided, and it should be maneuvered and also manipulated according to the needs. Another important thing is of course, the homogeneous distribution. When we speak about homogeneous distribution, all of the structure, multidimensional distribution is essential to be composed of. And homogeneous distribution is bringing you a more meaningful content and production processes. Some of the molding regions are not, of course, distributing the fibers at some certain directions. And those directions of the fibers in different axes, of course, bringing a weaker or a stronger structure. And for this reason, it is very important to look at the volume of the content of fibers. And when we look at the fibered concrete structures, what is important and what is essential? Of course, they should be resistant against actually the content and also the crash, and also some of the fresh concrete types may have some cracks in the micro level and macro level, and it is also preventing this micro and macro cracks. And of course, its resistance for shearing resistance and also bending, it is increasing the resistance, and also there are different parameters and bringing contributions in different levels. And another, when we look at the ratios for abrasion and for corrosion, and also when we look at the bending, it is reaching up to 200. And when we look at the cavitation erosion resistance, it is changing between 200 and 300. With the adding of the fibers. And of course, there are different types of fibers, which you can see on this table. Generally, the steel fibers are preferred majorly in the field, and both for their volume, weight, and also the mechanical features, they bring out a very high level of performance. And especially according to the developments of the fiber technologies, different producers do have new fiber sources, and every other day they are gaining superior features and providing us to create new concrete types. Actually, I'm going to focus on the glass fiber, which is our main topic. Alkali resistance glass fiber inside the concrete is being used. Why we are using alkali resistance glass fibers? Glass fibers do have different types and sorts, and a composite production, which is widely used, is the glass fiber. Alkali resistance is not so well, and for this reason, the cement inside the cement actually structure, when there is the alkali, it is causing a deformation, and it is causing the destruction of the structure. And for this reason, they are not widely influenced. When we speak about the alkali resistance glass fiber types, they do have 16%, more than 16% of an additive, and against the alkali environments, they are more resistant. And when we look at this, it's actually the 4,000 megapascal is another value, and the maximum actually extension capacity is reaching to 200, 220s and more than 200, 220s, as you can see. And actually, what is important for the reinforcement of the concrete? Reinforcement of the concrete is being enforced with glass fibers in this topic, and in order to create the concrete actually blocks, and by making use of some steel sticks, and also with some certain integration of different components, it is possible to reinforce the concrete structure. But moreover than that, it is possible to reinforce the concrete by adding glass fiber feature. Besides the steel fibers and, of course, alkali glass fibers and basalt carbon fiber type of different types of actually technologies, fiber technologies in different levels may be added, and different features of the concrete can be reinforced. When we look at it with a simple mean, as you can see, a simple structured concrete, and when we look at it's actually, there is a structural change when it doesn't have any constraint and a straining contained. And of course, when we look at the energy capacity, it is very high in the formation rates, and the cement composites are possible to be gained from the structure. GRC or CTB. What is GRC or CTB? Let me make the description of this first of all. When we look at the glass fiber reinforced concrete, the high performance cement, and also alkali resistant glass fiber, and also thin aggregated minerals and polymer structures are being mixed together to make it more resistant. And also, of course, alkali resistant glass fiber is creating the biggest mechanical structure, mechanical resistance, and also beyond that, different behaviors of the concrete for lessening the crack amounts, and also providing a higher actual performance in production. And of course, when we compare it with the traditional concrete, of course, they do have a higher value, performance, and also cost criteria are making it a very actually ideal product for the final actually users. It is providing different types of products and different types of structures, and they do have an environmental friendly features. This concrete type has different types of actually structures to be used. I have placed some of these examples. Of course, the facade coating is the first step which is being used, and of course the permanent molding, and also the closing of the roofs, coating of the roofs, it is also being used. And also in the construction of the different structures like the fringes, and also as a sun blocker, and also artificial rock systems and drainage channels, and also city furnitures. And it is also being used as a noise barrier. In many parts of the world, it is being used as a noise barrier. Glass fiber concrete has got the absorption feature, And last but not least, our recent researchers are pointing out us the fact that in the structural enforcement practices, glass fiber is providing a great opportunity in the renovation and restoration of the historical buildings, and also in different types of concrete reinforcement activities. It provides a huge opportunity. When we look at the technical features and compare it, glass fiber reinforced is, of course, pressure resistance is 20 and 50 normal, actually, concrete structures, but it is reaching up to 50 or 80 in GRCs. And also, most important feature is the bending resistance, of course. LOP value. In the matrix structure is showing us the resistance until it cracks. And it is approximately 10 megapascal. And when we look at the bending resistance MOR value, it is reaching to between 18 and 30. When you produce these concrete types with some weaved fibers, these values are rising. It is possible to make them better. In elasticity modules, it's approximately in megapascal value 10 and 20. And water absorption is 3 and 10. In GRCs, of course, it is possible to make the absorption level higher. And because of its structure, it has got a carbonating in-depthness in millimeter values, and the thickness is changing between 10 or 15 millimeters in facade coating. And there are some, of course, thicknesses below 3 centimeter. And the density is changing between 1.9 and 2.2, and the weight is changing between 25 and 45 per meter square. Why? We are preferring glass fiber reinforcing. Why do we want to use this? Yes, it is providing a high performance, and of course, it has got a resistance in different impact resistance is very well, and atmospheric conditions like freezing and also dissolving has got a high resistance, and also it is possible to produce it in a thinner actually component, as a thinner component, and different geometrical or the surface concrete production is possible to be made. And it has got, of course, the color options, and by the using of white cement, different visuals and visual outcomes and structural or coating elements can be produced from this glass fiber structure. And the architectural world is really in favor of this product because of its diversified options. And it is increasing day by day. And all of the maintenance conditions, and also when you look at the different structures, it is bringing an advantage. When you look at it as an advantage, it has got a visual, of course, advantage with its colors, with its appearance. It has got a very diversified color scale. When you use it with the white cement, it is possible to make use of different combinations of color pigments. Many actually, like terracotta tone, for example, colors can be provided in different varieties. And these coating concretes can also be colored afterwards, and it is possible to multiply the scale, the color scale. The surface textures is a very important feature of it. I mean, the surface texture is related with the molding technology. Any type of actually surface textures is possible to shape the glass fiber, reinforced concrete, and the molding applications, starting from the wooden mold and also polyester, polyethylene type of different types of actually molding types can be used during the production processes. The thickness, the depthness, and the, of course, size of the molds are changing. And when we look at the sizing of the forms, up until now, it is an extraordinary, a wide-scaled, and also a very thin, actually layered type of product. So it's a very special type of concrete which is being produced. And the major limitation is the logistic limitation. The transportation of these products, the architectures are in need of such kind of actually aesthetic features at any size or at any structure. It is possible to obtain it. However, the transportation of these products is really making it hard to be actually managed. That's the only problem that can be counted. And when we look at the finishing surfaces, it is an aggregated finishing surface agent, and it is bringing different advantages because there are different types of applications which it can be applied. One of them is the sanding application. Different designs and textures are being created, and also acidic bath is another type of application. And another important feature is the actually reordering. The retarding agents, as a retarding agent, with its retarding agents giving a different structure, and with the pressed water, pressured water, and also a different type of finishings on surfaces possible to be obtained. And moreover than that, when we look at the surface features, natural type of actually ceramic ties are able to be applied. So it is possible to produce shell-like structures, cross-like structures by the help of glass fiber as a coating material. And when we look at the basis of production in CDB and GRC, roughly to say, our traditional concrete structures do have a higher level of water content, and polymeric changing polymeric content is changing between 4% or 3%, 7%. And some other additives are also being included. But most important thing to be added to formulate and to control the content, minerals, MTKs, SFs, YFCs, and UKs are being added. And glass fibers are changing between 4 and 5. And when we look at premix types, it is 2.5 and 4. And water cement ratio is 30-35%. There are different types of basic applications, like the, of course, the blasting technology, which we use. And other than the blasting technology, we do have the premix technology, and it is more durable for shearing resistance, as a shearing resistance. And the homogeneous structure and also the hardness of adding fresh concrete inside it, the leaf sizes are declining to maximum 6 millimeters or 25 millimeters. You see the application in the premix situations. The fiber is being lifted from here and is being flown inside the mold, and by spraying on different matrices, it is possible to fill the gaps in order to have less gaps. And in order to have a better matrix interfaces, the adherence is being actually carefully handled. And you see the molding of the process and also the molding process of the concrete blocks. And when we look at the general perspective, pressing and also the fibers revolving type of processes are taking, and also adaptation and wrapping and centrifuge and also manual installment and 3D riders are also being used as the other production methodologies. It's a very innovative type of approach as a 3D with a 3D printers. It is possible to make use of it when you produce. In the foreign literature, there are a lot of studies related with 3D printers. And hardened GRC do have different factors, and its features are changing according to date. When we look at the basic one, the matrix content and the ratios, and also fiber structures, and also adherences in the matrix, and the mixing, and also spacing methodologies and production methodologies are changing. And of course, another important methodology which defines the structure is curing, and also the chemicals inside the mixtures. Without spending actually any further polymeric features or structures possible to be used. And of course, the quality of the laborship and also the inspection is making us possible to obtain a better quality. And when we look at the concrete structures,
according to the study in these molds, we have glass fiber reinforced concrete used in these molds. Now it will be put on a steel carcass, and which will be installed to this concrete molded material, or it can be directly from this carcass, can be directly solidified with the concrete as well. After the use of sidings, and the logistics comes into place, and under appropriate conditions, and there's their transportation can be made. Of course, in the field, the installation teams also can very easily install it to the carrier systems by use of cranes. So when we go into detail, without taking too much of your time, I would like to say here is that in the structure, here you see the architecture view of the sides, and you can see here the structural shells, which are decomposed and put into a modular way into systems, which is actually good for logistics. And since it will be impacting the costs, we have to decide which technology needs to be used for the preparation and production, as well as installation. Various production methodologies can be chosen according to the designs. Of course, we have to look into the geometry, the service loads, the window placements, and similar issues as well. As you can see here, different various forms can be produced for surfaces, especially for amorphous surfaces, and through a different molding performance, let us say. But all these molds that are prepared either from polyester or polyurethane can be used to mold concrete and then finalized with a spray as glass fiber reinforced concrete works. Here is the steel carcass system on which it is installed. As you can see during the installation, in a safe and secure way, the structure is fortified and solidified, is designed together. Of course, when designing these connection structures, connective structures, we need to be sure that the special requirements of safety are also met under utilization conditions in the world. There are various insulation equipment producers worldwide who are complying to these safety procedures. As you can see here, the production of the equipment is also important here in the installation stage, which you can see here, and the equipment necessary for installation, as you can see here, are tested also to see whether they have the performance stated in the project briefs. So performance tests are applied also to the installation and reinforcement factors. About precast siding in the systems where these details are solved, you can see here the structural examples. For example, in our country, Mardan Palace is the sidings here, which were applied with glass fiber reinforced concrete. As you can see here, there are much more complex examples of these sidings as well, with various usages of methodologies. Different fixtures and designs can be combined. This is from Ankara, a building. You can see here the entire siding except for the windows are carried out with glass fiber reinforced concrete. This is from Moscow, a swimming pool project. As you can see here, I would like to draw your attention to the artistic side as well. You can see here many artistic works carried out for the sidings, for the facades with the concrete factors. These are all quite lyric in their applications. Another example from Antalya. Here you can see here outer siding combined with lighting factors for a beautiful application as well. Here another example from Istanbul, Pandoria shopping mall for the outer siding, one of the different methodologies and molds. And you can see here with quite an aesthetic view. Apart from these, another example from the world is the Parliament building of Georgia. And you can see here the entrance is again a full shell designed with glass fiber enhanced concrete, reinforced concrete. Again, from our country, a residential project here for siding. You can see here glass fiber reinforced concrete. Here another project for the outer siding, example of similar methodologies of concrete. Here again in Dolapdere Art Museum, you can see here for solar deflection as well as for other advantages, this outer siding was preferred. here again, the project East Marina has preferred this white colored elements for outer sidings. I hope my presentation was beneficial for you. I thank you very much for your interest. And if you have any questions, I would be happy to answer them. We would like to thank Dr. Subashi for his very informative speech. We do have a few questions. As you know, white cement is used for precast and is already in the market. The implementations are saying that there are some cracks with GRC applications, especially for wide and broad application fields. What should they be careful about in such cases and to prevent it and to be careful about? Of course, in concrete, is actually an indicator that the cement design and projection is not appropriate. Maybe the percentages of the agents, the expansion agents, or other additive ratios and rates needs to be checked through a detailed analysis. And I believe that when these rates are correct, there will be no troubles. And sometimes, very rarely, this could have to do with some the problems with the finishing material, with the covering material, and sometimes some of the finishings have some chemicals that might counteract with the cement and the establishment of the concrete strength in the lesser degree. So you need to be careful about that. Thank you very much. Another question is this: when choosing white cement for precast applications, what should we be careful about? And as you know, sustainability is a focus for recently. What should we be careful about sustainability when choosing our cement, and how should we adapt to changing conditions? Of course, the most important thing that the cement production industry is facing is production of cement with less carbon footprint. But I do believe white cement is one of the best developments in that sense for sustainability. There are some types of cement especially beneficial for the precast sector to prevent cracks in the mortar with some reinforced varieties might be able to prevent some problems in this area, and do believe that this will also be beneficial for reducing the carbon footprint of the cement industry as well. Again, this white cement used for concrete production needs to be additive-free. Variety, calcium carbon, metacarbon, or buscolite could be preferred for more white tones. And that could be easy to implement for different colored versions of concrete. And this will also be beneficial in preventing cracks as much as possible, especially for shell concrete applications. Thank you very much for your most valuable information. Thank you. Thank you. We will now continue with our program with the digital and sustainability transformation of the cement industry. Welcome. Thank you. Hello to everyone. I hope you can see my screen. I am Dr. Zeynep Başaran from Özyeğin University. Today, I will be talking to you about the state of things and as well as what we are doing to keep up with it. And as everyone mentioned, in the construction sector at the moment, one of the most important focuses is on sustainability, and it has to do with waste management and usage of material or green material is already in our agenda for sustainability. But now we have targets as well, which were determined by the Paris Accord and the commitments for zero carbon dioxide emissions and, of course, reduction of global warming by 2 degrees. And it's just also a very keen commitment. This actually requires what we call a breakthrough. Of course, you need to have, we have our task cut out for us as the producers, as the designers, as the academia, because it requires a very different outlook towards this sector. And according to the most recent reports of the EU and the academia, has to do with 2 steps. The first step has to do with breakthrough developments, is to have the cement industry or the construction industry actually cage in that carbon dioxide and give it back to recycling. This it requires great budgets, very high budgets, because we have very high capacity production as well, and it is highly costly as well as very difficult to implement and to practice. And the second step has to do with the management of the waste of cement factories, maybe reuse of this waste material, or usage of waste aggregates for, again, cement and concrete production. And last but not least, is very important for this webinar as well, is structural optimization. And what's important at this point is the usage of precast concrete. And following in the footsteps of Europe, we see whole buildings constructed by precast elements, including the beams and walls. Everything needs to be brought into the field and used in the construction. And we need to do this as well. When I look at, for example, look at the building that I'm looking to, it could be built in 6 months with precast concrete. We're talking about one of the most largest construction buildings in university, Özyeğin University. The faculty building was completed only in 6 months, only with precast concrete. It's not impossible to do. You just have to have a very efficient workflow. And of course, some challenges that you have to overcome. And the greatest challenge here is the absorption of carbon dioxide and for capture for carbon dioxide as well. We need to have a more efficient utilization rate for this. And of course, for a concrete efficiency, there are some question marks. You need to optimize for cost and price, and you need to have a balance among this. So because we want a sustainable concrete on one side, and you have to use high performance concrete as well for efficiency on the other side. So this is all, like bottom to top view on how to solve these issues. This is what's stated in the report, and simulation is also carried out in this EU report, which says that what could be the rate of carbon dioxide reduction until 2050 for suggested technologies. As you can see here, different scenarios are there for breakthrough and to concrete and structure, because we actually can reduce it, but we want to go for zero carbon dioxide. So we want to have the most efficient application. And we see that precast application is seen to reduce carbon dioxide by almost 70%. And this is actually, when modeling this, I couldn't really get the transportation part, because I don't really know whether the carbon footprint of the trucks and transportation costs during this circular economy was also included in this report or not. But in total, we see that this is actually a very efficient methodology, completely aligned with the Paris Accords as well. And so in that sense, we see we need a very broad perspective towards this, where everyone can take their part and add it to a holistic outcome for cement industry. And I wanted to also talk about what we are doing at the moment. Of course, you know, we can have what are our R&D applications and practices as well, because, you know, in the future, we can even be in a position to construct a one-story building only with 3D printing. And this is actually what is our R&D is focused on. Sustainability towards zero carbon dioxide is the utilization of recycled materials and reuse of waste materials and digital manufacturing through 3D printers. Actually, what we're doing is not truly digital manufacturing, it's still 3D printing, but there are many steps as to how we can optimize this in the field construction, in factory construction, and production and manufacturing, combined manufacturing, mixture manufacturing. And this is all very important, and also reuse of in that sense, material which will allow for a longer lifespan. And we of course, besides lifespan, we need to have, in that sense, also the concern for the environment with using less additives and less agents and less extra material, and using geopolymers as binders or earth materials for additives. These are all a part of the processes of R&D that we are carrying out at the moment. These might seem little too much of a fantasy at the moment, but it is on its way. It is in the pipeline. I want to today, for example, talk to you about what we are doing with concrete through 3D printing. It's actually, it might sound a very recent application in the last 5-6 years, but it has a long period of preparation in the 20th century, especially in the background. Although there are no standard quality control methodologies, it can, in practice, construct up to 5 or 6 story buildings in the United States. You can have an entire neighborhood printed in this way. But what is going to be the perspective? Are we going to print precast elements and combine it in the field, or are we going to have this printing process carried out in the field itself? What kind of an advantages we have? There is no molds, there is no waste material. So actually it optimizes resource utilization, and it is fast in terms of manufacturing, and it is reducing labor force as well, and thus increasing security in the manufacturing area as well. And I cannot, for cost, okay, it's a question mark. I can't say it is actually cheaper at the moment, but when you think of the cost of mold and the cost of labor force and other areas and waste management, we can say that they're at least that it is break even, maybe, because, you know, you don't have to use molds anymore. You can get one 3D printer and use it for a very long time to print various materials as well. So what kind of concrete is to be printed here? That depends on the printer, actually. We cannot just say, well, this type is appropriate for printing. You know, there are some printers that can work with a very hard material, what we call remix, and it's manufacturing it through pressurizing it, and you can hit it like maybe a tile can come out of that printer, or you can have a much more fluent material produced and printed through textilotomy and in a very fast methodology. So we don't have a single right or wrong or appropriate material for printing, because there are different types of printers, and different types of materials can be printed based on the types of these printers. I think, yeah, that's it. It's back. And the material needs to be reworkable, and this is actually this is a thixotropy of the material in itself. This is a system in itself. The material and the printer needs to be in communication, and an optimization process and coordination process has to be carried out for this. We can play with the materials and using chemicals, and maybe use the timing of the finishing. We can use fiber to reinforce it for especially early stages, and we can rework it through clay. So everyone has a difference in terms of design, but at the end of the day, it comes out of a nozzle and it is workable and printable material. And then in that sense, it is an optimization. From the printer side, we can have a tank design for printable material, or pump design for material transport, nozzle design for the printing resolution. We want to have this easily very practical in the field. So not a gantry type, but a different type of printer that could be more practical in the field. So we're trying to include the printers in this renovation phase, in this R&D phase, in that sense. Well, what about the speed of the printer and the alignment of the speed of the printer with the structure of the material? So we can have a material design for each printer, and we can adjust each printer for different types of materials. So in that sense, they're interchangeable. So what's important here is that it's extrudable, so fluid enough to be extrudable, but it needs also to be workable. So it needs to have a basis strength initially, especially to be able to have a strong basis and fundament. So it needs to be fluid until it comes out of the nozzle. And after it comes out of the nozzle, it needs to be printable layer by layer. That's where the chemicals come into effect, basically. So after the printing, we need to have a yield stress evolution in the printable concrete. And that's where we need incorporation of thixotrophic agents and properties. And we have different approaches in that sense. Here, we can have ordinary Portland cement, and we can have mineral additive and calcium limonate cements as well. Duopolymer mixes are very advantageous here because it can provide instant workability. Some revalorized end-of-life materials are sometimes very important. Biological additives can also increase the extractive properties. Nanomaterials are also possible to use. So the concrete design is also adaptable to digital manufacturing. The most important issue here is the ratio of sand. It's at the moment 1 to 1.5. So we have what is reported is up to maximum 2 to 3 millimeters of sand, which is actually too small. We need to have the same volume of micro concrete or micro mortar that we need to be produced. I wrote here 25%, but that's too optimistic in that sense. We need to use 2 to 3 times more cement there. So this means, in fact, that the world is moving towards digitalization on one point, but to be able to do that, we're taking a step back from sustainability in terms of being able to print concrete through cement, use of more excess cement. So we need to have renovation and R&D exactly at this point. So we need to work on how we can reduce the impact of the carbon footprint for this digital manufacturing. This is where the nanopolymers come in. This is where the biological factors come in to replace the ordinary cement. Here, actually, we're using a cephalite clay here, which is very often found in Spain, in Turkey, and it's actually limestone. So it's something we use very often culturally. It's a waste material that we use very extensively. And this clay is used as a standard clay, but it also has microfibers, and this allows the material to have its very own skeleton structure to be able to stand strong in that sense. And of course, we also tried a nano clay to see the differences in our project. In that sense, we can have shear rates, as you can see here. It's a little bit specific, but you can see the values. When we look at quality control for 3D printers, we can have shear and slump and pressure resistance for standard concrete as well. So that's actually the basis, is that the problem, the challenge is that there is no standard quality control test as well. So we can only note down the biological properties of the printed concrete. You can see here how the rate of viscosity and the elasticity module and similar values are printed. But what's important here is the control to rate flow curve, which is actually a very important factor in determining the quality control and alignment of this material, because it has to do with being able to extrude the materials. And here we looked at, therefore, the shear stress and dynamic yield stress and the thixotrophic values as well. And we see here that this is actually acting as a viscosity controlling agent, and the printing can be in that, therefore, carried out step by step and layer by layer. We had actually designed this for Çimsa for calcium aluminate concrete. This was actually through the formation of a silicon gun to a robotic system, so to say, but it's basically a very basic material. So it's actually a silicon gun utilized by a robotic arm. We wanted this because you actually eliminate human error here, because you cannot apply homogeneous pressure or power on the silicon gun, whereas this robotic arm is very, very specific in the rate of pressure and homogeneous power utilization. And that's how we focused on material design. On this, we tried various designs with no extra materials, only with nanoclay. We used only, in another example, only a viscosity controlling and regulating agent in the market, and have other pieces. And cephalite also realities. And the values, you can see here that we have different reactions to all the different additions of extra materials. So we thought there needs to be a measurement system for this, a quality control system, which needs to be integrated into the printer itself for actual effective usage of the printer. So we thought that in a closed loop, we can have a quality control system applied to the printer itself, and not just for the mortar, not for the materials, but for the printer itself, to enable both to optimize themselves within a closed loop system. And here we see that our own printer that we manufacture has different properties through we see different analyses for printing material for different extruders in that sense as well. We actually determined maximum minimum values within which that printer can be used for that material. And also there is another biological additive factors, mixtures, biocrete. So for biologically positive cement and its bacterial cells to rheology modifiers. It does have a few challenges of itself as well. It's the innovation. Our project worked based on working to solve these challenges, and combining cephalite or adding a certain amount of cephalite and bacteria to the mixture was a positive outcome for our study. We didn't have a too thick mortar, but not too fluid mortar. So we had a very appropriate mortar and flow. I don't know what kind of molecular difference there is. I cannot explain the technicalities of this, but we had a wider printable area through this. And all this material actually allowed us to have a more homogeneous outflow.
How we have started this 3D printer? By the help of Çimsa, we have started. And we have started with Sibel Hanım, with a white cement, a white Portland cement, and Çimsa's Recipro 50 calcium aluminate. We have tried how we can make it to white, and at the same time, how can we provide an energy? Can we bring it a social benefit? We have started just before the pandemic, a few months ago from the pandemic, but we have had some very good results before the starting of pandemic. Çimsa's general design parameters, like the use of gypsum and also sulfate, and powder dispersant and super plasticizer has been used. Silica sand, polymer additive, and polyamide fibers were used. And we have designed a white cement. And at the same time, phase-changing materials were also added in order to make energy efficiency, provide energy efficiency. Because of their round shape, they have helped us during the extrusion phase. We have started with some small experiments. We could not bring them to rheological experiments. It was just before the pandemic. And indeed, different types of parts have been provided. What was beautiful about it? According to the dosage that we wanted, we were able to wait for 5 minutes and we were printing it. We were waiting for 10 minutes and we were printing it. We were able to change the nozzle sizes, and they have worked in different ways. Some of them is it possible to squeeze it? Is it possible to use it in different nozzle diameters? How speed can it be? Because it was speeding up very easily because of it's depending on nozzle type and printing speed. Actually, it was possible to have a very fast printout, and we have had this result. The other project started later on. This was the first step we have started, and we have learned. We have made a lot of mistakes, and we have learned a lot actually from our mistakes. However, what is the main topic here? The white cement and also the additive content, because of its environmental impact, will be the striking point. We need to approach it from an environmentally friendly way. And for the cement, what we are thinking, what we are actually committing. We are developing bio-based healthy agents, and more than 10 years, we are developing these products, and 4D is actually facade coating and also obtaining power additive, and also to implement technology with gamble mortars to reduce duration of heat curing for demobilization and improve the printability of the mortar. We have added, and we have applied a microwave, and we are producing coffee tables and also waste bins with these 3D paints. And we do have an EU project, cement project. All of the waste of mines and ceramic and also other waste materials are being recycled and being reused. We do have such kind of an upcycling project. We are a very huge research group, not only students. We do have the mechanical engineers and industrial engineers and also civil engineers. And many of our projects are being supported by TÜBİTAK. Thank you very much for listening to me, and I'm passing the floor to Sibel Hanım. It was a great presentation, Zeynep Hanım. 3D printer topic is a very hot topic. And everybody is curious about this, whether they do it or not. especially in the cement actually contents, they wonder about it. When we think about our 2 years ago studies, we have had a lot of trials and we said, okay, no, that's not okay. That's not okay. Let's stop. But we do have a lot of customers. Almost every week we are receiving questions about 3D printers. How can we manage it? What type of problems may occur? We do have such kind of a question right now in 3D printers, how we can actually develop the processes. What can we do? What is being wondered a lot? It's printability without actually distorting the layers, how we can print them, and how we can manage the operational duration. How can you respond to this question? Actually, this doesn't have an exact answer. If you are going to print a very long wall or a very big element, we are actually adding retarding element, not to cool down. If you would like to print something smaller, they are actually adding a different component. Just a retarder is being integrated, and the ideal condition is using retarding agent. And the present printers may also be integrated. It can be a tool which can be integrated in many parts. We are not using anything to speed up the process. All of the chemicals are creating, that liquidifiers are creating as actually slow down effect. And whenever we do have some operations, actually our cable printer is going faster, and sometimes for the optimization, it is not possible to say that we have found out this solution. We are using a lot of additives, not only the accelerator, but or the retarder. And we are using liquidifiers and filling materials. And the recipe is not very simple. It seems to be very simple, but from present components, additives, it is possible to use different components. I do not want to mention any brand, but it's a very complex type of design structure. The construction chemicals, like the retarder, accelerator, rheology, also type of rheological agents are being used. Thank you very much, Zeynep Hanım. I follow your studies very closely. I thank you. The third topic of our meeting will be thermal insulation plasters, and Metin Davras will be taking the floor. Metin Hocam, welcome. The floor is yours. Thank you very much. I'm going to speak about Precast. I will inform you about thermal insulation plasters. Now, let me start with thermal insulation. The efficient energy usage can only be provided in buildings by the help of thermal insulation. Energy export is $60 billion. Heating, cooling, and air conditioning expenditures reaching up to 17 billion for construction in Germany. In order to heat up and cool down building, between 30 and 60 kilowatt per hour per meter square is being spent. But on the other hand, in Turkey, it is 250, 350 kilowatt per meter square. And of course, 75%, more than 75% of our building stock is not insulated. In when we compare ourselves with Germany, what can we do? How can we do? I mean, when we look at the insulation and the, of course, gain from insulation, this is going to reach up to 50 billion per year. When we look at the European standards, insulation materials, actually coefficients value is reaching up to 0.065. And when it is beyond this, they are being named as the construction materials. And when we look at the coefficient number of insulation value of a material, actually it is good for insulation, but it's all alone do not mean anything. If the heat insulation performance of a material is low, and if it is not actually taken into account with the thickness of the material, then we cannot speak about the real means of insulation or the insulation resistance. Its coefficient value can be low, but if the thickness is sufficient enough, we can really speak about the insulation rate, insulation factor. Another important feature to define the heat insulation, of course, thermal insulation, the fire classification of the material, according to 2015's code, according to the regulation of 29,411, the buildings which are higher than 28.5 meter, which are classified as A1, A2 type, and also should be, of course, prevented, should be resistant to fire, and of course, they should have the C-type materials in content and construction. And for a long period of time, actually, in our country, when we look at the insulation materials, EPS or XPS, actually, we're using as the extension material. Now it has been replaced with the thermal insulation plasters. And when we look at the traditional thermal insulation materials, the unit price for EPS is the same value, the lowest value. And when we look at the external facades and of the buildings, and when we look at the fire types, that importance, of course, factor, I mean, the firefighters situation for the flames, of course, is being very hard. This is the Grenfell Tower fire in London on the 14th of June, 2017. Starting from the second floor, it has taken under control the whole building, the whole facade, distributed to the whole facade. Unfortunately, 79 people have lost their life. And the firefighters actually intervention took 24 hours to extinguish the fire. When the building is higher than 28.50 meters, of course, the flammable materials, A1 or A2, non-flammable materials, A1, A2, and also the flaming retardants should be used in the content. And of course, when we look at the systems which are less than 28.5 meters, of course, it should be coated, 1.5 meters should be coated with non-flammable material. And if the building height is more than 6.50 meter, then the windows and window panels and all of the voids at the edges of the building at least 15 centimeter, or from the upper side, 30 centimeters should be coated with the non-flammable barriers. And of course, it is possible to make use of some other materials like non-flammable other than flammable. Of course, there are fireproof materials, fireproof insulation materials that can be used independently on the facade of the buildings. And traditional thermal insulation lacks a mounting approach is causing some problematic issues due to the structure of the surface. And of course, they are sometimes not being prepared according to the appropriate techniques. And of course, the mounting process, during the mounting process, sometimes the number of the packs, the pins are not being sufficient enough or unqualified. And of course, the wind load of the building is not being taken into account. So misuse of or less amount of pin usage is causing problems and taking the whole insulation panels off the building. And of course, all of the plates, all of the sheets are being off the building. And these plates are not being replaced, are not being mounted again. And of course, the void between the insulation, thermal insulation plates are being filled with cement, sometimes with some foam. And so this kind of disqualified type application, making the structure of the building weak. And due to some different reasons, of course, application failures, it is possible to have less insulation impact. When we move towards a thermal insulation plaster, the Ministry of Environment do have, of course, regulation and legislation, and also standard TSEN 1998/1 is a standard which we cannot ignore. And the basic actually condition of this insulation plasters, thermal insulation plasters feature is it should be less than 0.065 watt. And in our country, more than 50 companies are present which are producing thermal plaster. In order to be named as an insulation plaster, the value by these more than 50 companies, the value of 0.065 watt /MK should be taken into account, should be provided as a standard. We don't know the numbers. Of course, the components, there are some basic components. When we go through this, the basic components, some chemical components are present. When we look at the expanded, of course, extended perlite is present. About perlite, there is one point to be underlined. World reserves 250 of the actually types are being owned by Turkey. Turkey has got a huge source of perlite. Construction business is not giving enough importance to this, and it's a big question mark. Additional to that, light glass spheres, which are providing actually resistance for thermal heat, actually thermal protection in the last 10 years. It has been used. And also granulized iron is the latest actually product for the pressure resistance. In order to insulate the structures, granulized type of aerogel is being used. And it has started to be applied in some European countries. Since we are speaking about Çimsa, we need to speak about environment. The basic component of thermal insulation is the white cement. It's an obligatory, mandatory component. And of course, it is also possible to make use of powder lime because the adherence of the material is being increased, and also according to concrete cement, it is coefficiency number is lower, 15%, 20% lower. And when we go through the chemical additives, CMC type of powder cellulose, and also we do have dust polymers are present. These are the basic two components. And in order to have less water absorption, we use perlite and we use hydrophobic agents, water repellent hydrophobic agents. It's a mandatory condition to be owned. The thermal insulation plasters do have 4 basic features. And of course, the hardened actually mortar is having a high density, a dry density. And of course, heat permeability is very important. And of course, when we look at this plaster type, the dry unit volume rate is 300 kilogram per meter cube. And when we look at the heat conductivity, its coefficient value is 0.065, and the pressure resistance is 40 kilopascal, and capillary water absorption coefficient is, as you can see. Now, what is different from the traditional thermal insulation plates? Actually, the surface is not necessary to be prepared, and also you should not dig the carrying instruments, the carrying walls, and it is very easy to maintain, and it doesn't need any additional material, and it is flexible in any designs, so it is not a rigid type of plate, and of course it is not creating any waste. Additional to that, when you start to use thermal insulation plasters, there may be some certain problems which we can come across. First of all, craft bags are used in order to transfer the product, and also water is being added, and also it is manually or with the help of a machine being mixed. And partially the biggest disadvantage is the heat conductivity value. It is not actually being fixed. It is not being permanent. And capillary water absorption and mechanical resistance problems may also occur. And we do have very low amount of studies in our country, in our literature. Only Akbulut's study is actually very well known in 2018. And in this study, what is being widely used, TS-EN 1998/1, 5 different companies have prepared samples from their thermal insulation plasters, and their bending resistance, and also pressure resistance, and mechanical features, volumes, capillary water absorption, and heat conductivities have been examined.
And the appropriate samples have been here researched, and you can see here 2 out of 5 samples are below the value, while the other 3 are actually above the 400 value. And here, Again, you can see here the water absorption coefficient here for insulation plaster, 5 samples. And you can see the results. And see here, 3 of them are above the 0.8 level. For pressure resistance, you can see here's a function of the unit volume mass. And so for 28 gram, you can see here the results of the 5 samples again of the insulation plaster. So 3 of them are again above a certain level. For heat transference levels, coefficients, we can see here heat conduction coefficient, and you can see here again the results of the samples. As the volume grows, we see that its thermal conductivity is also changing. 2 of the 5 samples are based on the standards, are quite above the required levels. The other 3 are below the level of 0.10, as you can see here. This means that none of these insulation plasters are actually given in the results here. Of course, this is based on the specific study, but of course, rather than responsibility for producers, we need to have, I would like to say that they are the appropriate equipment for the measurement of these properties are actually one of the reasons that some misguiding conclusions can be reached for the measurements and tests for especially thermal conductivity. We need to have heat chronometer and a Hess machine needs to be used with a hot plate methodology. And of course, the calibrations of the measurement equipment is very, very important. I would like to emphasize once more. And of course, the conclusions, the results, the measurement results needs to be repeatable. This is another important factor for the significance of the results. So insulation plasters are products that can be used with exterior as well as interior wall systems as well. So we need to have aerogel added high performance insulation plaster, which was developed and turned into a commercial solution in a very short time, especially new plaster with a mineral essence can be used for original historical building materials, as well as for interior as well as exterior surfaces. The new material proposes an ideal solution in this sense. In Europe, for private and special projects, of course, since it's about Europe, I had to give a brand as well. You can check it. Fix-It 222 is the brand, which is a special mineral plaster with granuled aerogel in it, with white cement, and also a binder with high performance. And it's also especially for historical buildings and buildings under protection are the areas where Fix-It can be used for both internal and external walls. And here also, we can say that the values are, in that sense, are for thermal conductivity and capillary water absorption and water vapor diffusion resistance are given, as stated in the slide. But I have to say that the aerogel has a high cost as well. So this causes for the unit sales price of the plaster to be higher than the other varieties. When we look at the fluids without aerogels, we can see, I've been focusing on these for a while. We can have a unit, the dry unit volume mass of 240 to 280 kilogram per cubic meter, and can have the thermal conductivity and pressure resistance and capillary water absorption values, as you can see on the slide. And sales price is among $0.6 to $1 per kilogram for these non-aerogel products. And the fundamental agent is white Portland cement. For the insulation plaster. As for the thickness, we can say that it can be used for different regions, and different application thicknesses are valid. Also, as for white Portland cement, and also combined with materials such as other binding materials and incrustation materials, and added together, it will be, as pointed out here, causing a very good result. So the incrustation ensures that there is a lower heat conductivity. As you can see here, the different values on the slide. So as a result, I can say that certain thermal, mechanical, and physical properties need to be maintained These being maintained, these heat insulation plasters are an alternative material to the traditional heat insulation materials. And of course, the producers need to refrain from misguiding statements. And of course, quality control experiments need to be focused on, and frequent supervision and controls by authorities need to be conducted in that sense. And of course, support from the ministry level and public authorities needs to be maintained for R&D work, as well as from institutions such as pearlite producers and cement producers. And of course, industry, academia, cooperations need to be maintained for research into the topic, and these industry representatives, such as Çimsa, need to be very active in the research, as well as maintaining and setting the standards in the market for this new material as well. Thank you very much for your interest, and if you have questions, I will be happy to answer them. Thank you very much, Professor Mitten, and today, where we have sustainability and energy saving as a main focus, this was an important topic that you talked about. Thank you. I would like to ask a question. You, during a presentation, you touched upon a very important topic about the amount of water in the heat insulation plasters. And you talked about the disadvantages of not using the right amount of water for that. I mean, in the traditional manner, those in light aggregates, this is one of the most important challenges. You want to have a fluid structure, but you also want to have strength. So how would you actually say is the right methodology for the usage of water, for free flow water? You are asking about the plasters. No, more about the blocks when you are pouring them into the molds and using light aggregates. What is the methodology to use there? Well, let me put it this way. We need to have two steps here in this topic. First of all, for pre-mix insulation plasters, you need to have clusters, dates, and there you need to have 14 to 16 centimeters of broad area to make sure that the mortar is in the it is flowing out, to make sure that it is in the right composition and the right ratio. Other than that, we're talking about the utilization of these plasters for the blocks, and you might be faced with segregation and able to overcome that. You need to have additives to increase. You need to have the viscosity modifying agents. You need to have the correct materials applied in the correct ratio. Not all materials can work with the materials that you have at hand. So it's very, very important that you choose the right viscosity modifying agents, especially for products like light concrete with high viscosity. And you can have adherence increasing agents added to it as well. That would be a solution to that. Thank you. Another question has to do with perlite mortars for early strength of structure. What kind of agents can be used? Maybe not a brand name, but structurally, what would be your recommendation? What kind of well, when you talk about mortar and plasters, I would say that for plasters especially, since it does not have so generally calcium chloride usage can increase its strength. And then there might be some concerns about the effect of this material on the concrete, and also similar agents can be used. Thank you very much. We have one last question. For heat resistance of these perlite blocks, would they be sufficiently resistant? What would be the performance of perlite blocks for heat resistance? So I may say resistance to fire, I would say that they are named products. If there's a minimum amount of cellulose in it, it could be negligible. If we remove the cellulose, there is no organic based material. So this makes them class A non-flammable material. But if they want to have a refractor material, it is not possible to do that with traditional Portland cement. You need to have calcium based cement to do that. You need to prefer those. And also recent products are very, very successful for that, especially for refractor materials. I can very easily say that we have used them as a refractory material for our own facility, but with quartz aggregates. When you talk about perlite as aggregates, that changes a little bit, because perlite can come down to 1 centigrade degrees, where it avoids deformation, but 1,000 centigrade degrees, up to 1,000 centigrade degrees, it is not deformed. But over that, there's the issue of slight deformation. So I would say be careful about that. So if the aim is to have a perlite-based refractor material, you have a very limited range. For over about 900 degrees, you need to use more calcium-based. I would say Isi-40 is the, yes, Isi-40 and Recipro 50 are the products you're talking about, I think. Yes, those are the products that I meant. As one to up to 1,400 degrees and 1,250 degrees. Yes, these are the more heat resistant products that we have lately launched. Thank you very much for all the information that you've provided us. The fourth presentation of our program will focus on construction and demolition waste, and Professor Mustafa Shahmaran from Hacettepe University will be with us. Welcome, sir. Yes, thank you very much. I think you can see my screen. Yes. Hello. Hello to all participants and everyone listening to us today. A little bit different from the previous presentations. My presentation will focus on demolition waste and circular economy, integration to environment and the challenges and the outcomes. And of course, the circular economy statistics for construction and demolition wastes, certain practices that we are undertaking, and certain commitments and targets are what I want to talk about. I know that the main topic of today's meeting is Precast, and for such implementations, there is some visuals that I want to share with you that you can use such demolition wastes for production of precast as well. When we look at the construction sector worldwide, we see that the increasing population, as well as bad urbanization, as well as increased urban areas, causes this sector to grow in the whole world. And that means the demand for raw materials for the production and manufacture of construction materials lead to also other environmental factors, such as the emission of carbon dioxide gas, among others. And of course, at the end of the year, we see that all these construction materials cause sometimes very dangerous waste materials, such as asbestos, especially solid waste as well. So let's look into how Turkey is doing in all these regards. And after that, I will talk to you about more in detail. When look at the construction sector in Turkey, as in the rest of the world, we see that in Turkey also construction activities are focusing on linear economy still. So turning it into a circular economy is a main activity point, as well as more than 40% of the total waste is from construction, and it is one of the main producers of waste. And we have 1.5 million people employed directly by the construction sector, and about 12% of the GDP of Turkey is from this sector. So we need to focus on this sector as a factor for environment. So looking at the residence inventory in Turkey, we see that residential is actually a major part. And a very important part of that is actually independent residences, single residences. So we see that as Turkey, as we can see also, here's that the measures taken for the construction industry is insufficient in terms of the demand and the supply for residential construction. Of course, we see that in Turkey, during the population and the immigration is also leading to an extending need for residences as well as buildings, and by the resident population as well as by the immigrants coming to our country. Let's look at the challenges and look at how we can solve them. Another important challenge that Turkey faces are earthquakes, as in Düzce very recently. Unfortunately, Turkey is one of the major earthquake-prone countries in the region. We have more than 5 active fault lines, and with overpopulated areas. And we see that since the beginning of the 20th century, all natural disasters in Turkey has heavily damaged more than 700,000 houses and buildings. And of course, all this work leads to a lot of construction and demolition wastes as well. Of course, the transformation, law on transformation of buildings under the risk of natural disasters has been a starting point for a lot of activities in the construction sector in Turkey. And here we can see that apart from that, in the world also, there's an ever-increasing urban population as well as developing economies, which lead to a constant need for construction of buildings and bridges and highways, and as well as maintenance and rebuilding work, which leads to also demolition work. Unfortunately, in our country, of course, we see that within the framework of infrastructure and urban transformation, we are expecting from a total building inventory of 19 to 20 million, about 600,000 are expected to be demolished and rebuilt, reconstructed. And we therefore expect a very high amount of waste. And among the 28 members of the European Union in 2016, and we see that 37% of the solid waste comes from this construction sector, which makes Turkey among the ranking among the last of these EU member states as well. We are actually, due to demolition waste, actually wasting natural resources, and we need to have efficient solutions to minimize and mitigate and minimize these demolition wastes. And here you see the building lifespan and the here the utilization of resources and the building value change and emissions for different steps of the lifespan for the buildings. And you can see here when we look at different processes based on this lifespan levels, it causes significant emissions and land utilization as well. So all the factors within the value chain, the construction value chain, need to be included in the circular economy, which needs to be the basis of the new integrated construction sector in Turkey. Very, very important. I'm sure you've seen similar slides in the past a lot in Turkey, but I want to emphasize once more. When we talk about circular economy, we talk about efficient use of all resources and all products throughout the entire lifespan of processes, and renewable resources being used and reuse of waste, as well as prevention of value loss, and longer utilization and higher functionality of the products and resources are important throughout the circular economy. So the main philosophy here is that from cradle to cradle, product design here it's important. The aim, the target here is to have a higher utilization lifespan for products which is different than the linear economy, which says from cradle to the grave, but then from cradle to cradle, where the product does not end in an incinerator, but then is reutilized for the basis of a new product or a new process. So we need to look into it in the circular economy methodology. So when we look at a plan and schedule for circular economy, we see that demolition wastes need to be reoriented towards waste management companies to renewed processes and new construction methodologies. We need to have designs that are easily detachable and again attachable, modular, and prefabric construction are important. Closed circular systems for components, construction components are important. These are all factors of a basic strategy for this, and you need to have strategies for waste management and determination of the amount and quality of the waste materials at the demolition, and selective demolition methodology being used are among the factors which are important here. So after the demolition, we collect the waste, we process them, and we need to classify them on site. It's very, very important. So at the last stage, the energy saving and the transfer to waste areas are among the significant items to be considered. So even if we have the most economical solution, it's actually preventing the circular economy. So sometimes we reusage without any processing seems to be the most economical, most feasible solution. It is, of course, a part of the circular economy, but efficient recycling of the construction and demolition waste is actually more important in terms of standard quality, where the increased confidence of the consumers in secondhand usage. And finally, last but not least, using the demolition waste for filling material for new construction materials is very, very important. And this is important in terms of preventing value loss. And without all this, it's impossible to talk about the circular economy integration for construction and demolition wastes in that sense. It's very clear that it will have many important outcomes in terms of environment and social and economical regards. We need to have also socioeconomic factors such as employment or self-sufficiency, high added value, secondary materials, construction and manufacturing are among the various factors of these three groups of advantages in that sense. And the fact that there is no demand for such materials and a lack of purity and easy access to natural resources are the disadvantages our country has for a good and efficient circular economy in this sector as well. And when you have the cost of recycling higher than the cost of regular manufacturing is a disadvantage for us. And of course, politics is also efficient here. Maybe with additional taxes for first-hand materials, we could move towards second-hand materials because our natural resources are not endless and are going to stop at one point. So we need to definitely go to a circular economy in the sense.
When we look at another actually political measures, the green procurement or new cement types, green cement types, are also being added in the regulation and also legislation. And also beyond that, the incentives related with those, and also the criteria in order to be exempted from the waste classification and also developed producer responsibilities should be taken into account very seriously. We are speaking about a 50-year period, a service maintenance period, and for the construction materials, all of the extended producer responsibility in practice is not something to be applicable. And when we look at the duration and also the life time of a product, it is going to pass in other hands. And related with these issues, the changes and also the standards and variabilities and the lack of quality and standard and also application actually lacking points are very critical in order to be taken into account, and also wide scope laboratory analysis and classification of the materials. In the very end, robust databases should be the overcoming actually measures to be taken. All of the legislative and regulations and policies, incentives, certifications should be also taken into account, should be taking into account the, of course, insulation materials. And let me speak about the barriers and what are the solutions which are being provided in our country. The first issue, the quality of yes, and the basic condition to make it a standard, all of the risky type of structures should be selectively deconstructed, demolished, and with the pre-demolition inspections, they should be classified and hazardous materials should be somehow isolated. And all of these left photographs are showing in 2015, for the very first time, we have met this selective demolition process. And this is the 11-story building, Magnolia block, and we have had a selective type of demolition activity. And for the circular economy, it is one of the actually important feature to be taken very seriously. With the recent developments, 2022, the month of July, we do have the new regulation, demolition regulation. According to this demolition regulation, selective demolition is essential to be made. I don't know how much they will be practicing it on site, but we do have a EU project with Çimsa. The service of lifetime of actually this products and challenges, also opportunities. I mean, the construction demolition waste will be taken into account, its traceability, its management, and its efficacy and safety and performance are tried to be actually addressed with some digital solutions. I mean, the waste assessment and also the content and the need supporting systems and smart demolition devices, and also management plans and demolition plans, and also demolition decision process, staging and quality provision, and also cable-free innovative descriptions and verification, and circular economy related raw material statistics and cloud monitoring and tracing actually platform. Different actually groups and interdisciplinary researches are taking place. And also the good wastes are trying to be classified and are tried to be integrated in the recycling process. Another important process is the reusing of actually these materials in raw material production, and also it is aimed to measure their filling material as the basement material, as the actual infrastructural material, how they can be used. According to the results of the experiments, all of the recycled materials will be used the secondary raw materials. It is possible to do this. This is what we have observed from the experience we have done. We have not completely operated it, but we have followed this project very closely. As soon as these studies are completed, in 2015, technologies and of course opportunities will be replacing 15 or 20% of the raw material usage, brand new raw material usage, by making use of good wastes. And of course, these good wastes are composed of natural, are being replaced with natural materials, and they are going to be applied and upcycled. And there are some technological barriers. Another potential solution is Lego type mountable designs. Whenever you need them, you are matching them, bringing them together. And whenever you do not need them, you are demounting them and you are replacing them. In such kind of a situation, what is going to happen? IA will effectively transform and will be contributing to the recycling, actually, cycle of our country. Turkey and UK do have a collaboration within this framework. Low cost, environmentally friendly accommodation model is focusing on new generation construction system. You see visuals in this study. Of course, sustainable construction design is taken, and majority of the components are composed of good waste, and it is aimed to develop such kind of materials. And Hacettepe campus, inside Hacettepe campus, the first demountable structure has been constructed. I'm going to show it to you very soon. By the end of this December, inside our campus, the supportive services building will be used as a supportive services building. And anytime you would like to see, I can host you, I can bring you close. I don't know whether you can see the video or not. Can you see the video? Yes, we can see the video. This is the ready-made basement system, a ready-made basement system. I'd like to speak about that soon. Almost 100% is composed of this red actually bricks, and inside the cement we have integrated them, and when we integrate them inside the content, this is making a reddish color. It took us 2 days to construct this structure, and right now we are doing the last touches. It is demountable. You see the connections of the building. We do have such kind of a structure. With Çimsa, we do have another project that we collaborate, and different than the structure, we do have a real scaled, actually, demountable basement. And everything, all of the pipelines, all of the infrastructural features and components will be actually demountable. We especially wanted to see this in our new system. It is a totally curtained system. Right at the moment, actually, where do they come from and how do they actually classified, how do they managed and transformed and cycled? We don't have a high level of awareness. And of course, for the manufacturers and for the construction companies, it is hard to manage, and they are not showing a great willingness to transfer everything. And during the management of good, waste materials, in order to enhance and empower, it is essential to develop the practices, and such kind of applications should be supported. And of course, as a capability of traceability and throughout the supply chain, having a mobilized approach and also verification and provision of some certain conditions, it plays a crucial role. And for this reason, a cloud monitoring tracking platform and EV digital traceability solutions should be developed, and sharing information among the, of course, key actors, bringing transparency and also making use of blockchain technology to integrate the systems and to connect the systems. Çimsa is somehow included in this system, and it's an international project. As Metin Bey has just showed, insulation materials is really very important. As I have mentioned to you, for a long period of time, actually extended responsibility for the users cannot be ignored. It is not something that you can throw away by a single use. Actually, within the framework of this responsibility, Of course, AI needs to be implemented and integrated in the circular economy, and we should ignore the projects which are not taking into account this actually reusability and a type of actually materials which cannot be demounted. The traditional materials in our country in the circular economy will be creating a huge barrier, and we do not have any hesitation. So all of a sudden, somehow, this irregular actually operations should be stopped. In the slides, let me operate a video. It is really exciting us a lot, which Zeynep mentioned. We are mainly focusing on the waste and affordable issues. We are looking at the reasonable budgets, 3D painting technique, continuously. Concrete ink was being developed, and this was actually produced according to the construction code of conducts. And the part which is not being used in any construction, this green concrete, applying it and adapting it to 3D painting is more economical. In our preliminary calculations, these recipes are sometimes strange, but the 3D printing recipes approximately costs less than that. The traditional, it is very close to the traditional way of cements and traditional way of concrete costs. And with 3D printing actually methodology, the costs are declining 60%. This is what we aim to achieve. And also the construction wastes will be used on site for the urgent operations. We will be establishing a production system. This is in Ankara. And this printer was developed with a software company in a collaborative process, and 3D actually printing mechanisms is also increasing the amount of wastes on site. In 2023's first 6 months, we will be, of course, achieving a 100% of actually upcycling of the waste, and one-story building will be applied. Let me speak about standardization for the materials which will be used for the very first time, and also the construction of the actually materials. Of course, it is going to play a crucial role. Standardization is essential, it's related with commercial activities and also related with commercial certification in order to enhance the source efficiency and also contributing to the circular economy in the construction business, construction industry. It is essential to know safe and secure and standardized type of database, information system, a knowledge system based on researches on site. And in a project which we carry on, and this is the actually QR technology, like outfit technology. It is a contact-free actually technology. You see the visuals there, and also material passports at the same time, just like the building passports or circular action passport, the collecting and operation and processing of the actually database is being provided. The passports are composed of the components of structural materials and their circulation features, and it is cataloging them, and it is creating a construction value chain. As soon as we started to dig the base, till the end of the lifetime of that building, we coincide the actually related actors. And anytime, any place, it will be possible to provide any detailed information. In the previous slides, I have spoken about some modular structures. And the material which is being used is totally environmentally friendly, a traditional concrete, like actually Neve type of green concrete. Neve tradition of green concrete, Portland cement concrete, and actually Çimsa is also adding the cement, which is the recycled good material. In the life cycle analysis, we have compared and contrasted them. And when we look at the categories, the ones which is being 100% from recycled material, and its impact on the environment has got a superiority. And the climate change and also global heating, and also the carbon dioxide emission, and is being calculated by making use of the recycled material. All of the actually recycled and upcycled material is much more better than the traditional concrete itself. Last but not least, another collaborative action that we will be taking, carbon dioxide binding and catching potentials will be developed, and a secondary structural raw materials will be upgraded, and also circular solutions will be taking place. In the slide, as I have mentioned to you, most probably within a few months, we will have a pilot test. This new generation carbon dioxide capturing methodology will be bringing us a better physical features and do have some additional economical ingredients. And by adding some raw materials to these contents, this factory chimneys carbon dioxide will be binded. And by the help of this binding process, both the health and also the environment and economical actually features will be upgraded. It will be safely and securely will be used for the new constructions, for the new buildings. In our present studies, within a 1 ton of actually, you see the factory chimneys simulation. Within 24 hours, between 100 and 200 kilograms of carbon dioxide has been captured. And 30-35 euro is the cost, and we would like to decline it to 20 euros. And the global average is 60 euros. By the help of this, we will be staying at the threshold level, and we will gain a lot of actually advantage from the production side. In summary, circular economy strategies and also a product related with the circular economy, every single step should be preserved and protected. And the circular economy strategies, sustainability, verifications, and also objectivity, and also some certain tools in the circular economy should be applied. And environmental actually action should be controlled, and without losing any value, it should be also creating an incentive grant to reuse the materials. That's all I would like to tell for now. Hope that it was beneficial for all of the participants. It was fruitful for everyone. Thank you very much for listening us. And I would like to express my respect and gratitude to our listeners. Thank you very much, Mustafa Bey. When I'm watching your studies, I'm getting very excited, because such kind of detailed academic studies and bringing them on live, on site, and being involved in our life is something very good. I can see this in all of your actually studies. I'm really very happy to listen to you. You have touched upon very important, very good points. When I was listening to your presentation, something came to my mind. You have mentioned about the actually construction materials. Do you have any spatial sources? What type of sources we can use? What type of way we should follow? You have just mentioned there are a lot of big barriers, the prejudiced approach. When we use the wastes, for example, we are having equality laws, actually, whether it is going to decline the value adding feature. About the product quality, the practitioners do have some barriers. What type of sources do you recommend? Do we have such kind of information which we can follow? Actually, You are involved in many of these businesses, and we are having a very close relationship with Ayten. In order to actually get over these, we need to develop some certain regulations. In order to not to be counted as a waste, we should carry on. For plaster, actually, we do not make such kind of a study, whether it's a plaster or the brick. There are few actually types of bricks, and recycling materials and iron itself are majorly being used. And moreover than that, stakeholder of ours is going to, of course, use the recycled wooden in the recycling units. In the traditional actually approaches, what we think is also valid for the upcycled industrial symbiosis, actually mine wastes or different industrial wastes. They're all can be actually transformed into a conventional type of actually materials. Where we use the conventional materials, it is possible to use them in any place. We should not count them as a waste, and we should determine the actually conditions. We do have actually cars, vehicles, second-hand vehicles. What are we doing with them? Actually, we can do whatever we are doing with them is also possible to be done with the construction waste. Thank you very much for providing me this opportunity. The last topic of our meeting is the aerated concrete applications with white cements, and I'm leaving the floor to Ayten Çaputçu. Ayten Hanım, welcome. I think you have received my screen. Hello, everyone. I'm at Çimsa Arget team. I'm working as an alternative foil applications. We do have a study which we have actually developed. I'm going to speak about gas concrete. And when I'm starting my presentation, let me tell you what is gas concrete, what type of advantage does it bring us, how can we process, how can we classify it, what are the mechanical features, physical features, and also how we have developed our white cement and what type of actually benefits did it bring us. Actually, gas concrete has been defined according to EN 1771.4, and it is a silicated aggregated inorganic binding material composed of lime or cement, and it has got a porous structure, and it is the hardening of vapor cure, and also has got porous concrete structure, and there are different application areas. When you look at it, when you look at the process, there is, of course, silicium, there is lime, and normal conditions in Portland cement, which we know it, has been changed in our research with the white cement. And of course, in order to have those actually foaming effect, there is a foaming agent which we have used, and approximately 210 degrees Celsius they are being curated, and as a reaction of the materials with each other and with the reaction of lime with the connection with water, and we are having an aluminium reaction, and calcium aluminum oxidation is taking place, and with silicium it creates calcium hydronium silice oxides, and you see the discharge here. And gas concrete, as you can understand from its name, structurally 80 or 80% has got some actually voids, and for this reason they are high insulating type of concretes, and it has got a positive contribution. During the summertime we would like to have a cooler actually climatation, and during the winter we want a, of course, hotter warmer environment, and for this reason it is possible to recycle it, and they are very light in structure. During the earthquake times, of course, it is lessening the burden on the building and providing us a better actually condition, and all of the ceilings and also roofs and all of the actually binding features are easily being constructed with gas concrete, and it is more durable at approximately 4.5 hours actually. It is resistant to flames, and it is a non-flammable type of material. And when we look at their production in Turkey, approximately 4.2 million productions present in Europe, 16 million meter cube is being produced. So this shows us that gas concrete is very important for precast industry, and osmoland blocks and insulation plates, and also the doors, and also carrying instruments, and so exterior walls, any type of actually features and elements in your structure. By making use of gas concrete, according to the recent regulation in maximum 5-story buildings, by making use of gas concrete, it is possible to construct a building in high-story buildings. According to, by making some certain statistical actually calculations, it is possible to make use of gas concrete. When we look at the production phase, you see a mill here, and they are being grinded. And when you look at chemical composition, it is essential to be optimized and being measured. It is bringing into an homogeneous structure in order to get inside those balls. These are being molded. And you see the caking process. After putting it out of the mold with the automatic cutters, it is possible to slice it and able to be sent to the autoclaving unit in under high pressure and heat. It is being curated, and autoclavated material is being controlled, being packaged, and being transferred to users. When we look at the content, actually, all of the foaming system, whether it needs to be integrated in the beginning or the end, whether it is a lime-based or a concrete-based, autoclaved or non-autoclaved type of classifications are possible. And of course, these classifications do have some pros and cons. And today I'm going to tell you the super wide, and it is the autoclaved system.
So when you look at the physical properties of AAC, I said that as 80% or more porous materials, so micro and macro pores, their connections to each other are important in terms of the other mechanical properties of AAC. And when we look with scanning electron microscope, we look into porosimeters, into the porosity structure of these pores of AAC to see their interrelations and to see how it will interact with the capacity of the concrete. Another important factor is the intensity of AAC, and for certain intensity levels, we need to have more sand and water and aggregate to add it, because in a few cases, we might have the required intensity with the appropriate ratios of water and sand. It's important for the stability of AAC in the later utilization levels. When we look at the chemical properties, we have the ratio of calcium to silicium, and we see different chemical phases. One is gyrolite, another is terbarmolite and sonotolite, and CSH phases. So in that sense, for our study, we are focusing on tobermolite phase. We know that here the calcium-silicium ratio is 1.25, and this is the phase we see in regular concrete. And too much calcium based on increase of thermal degrees changes the phases to to transform the mechanical properties of the product. However, when your calcium solution ratio is 0.8 to 1.2, you have the tobromolite phase fixed. And we see that the crystallite amorph tobromolite is important for this phase with appropriate porosity is very much related to the stability of the concrete. And various materials come forth as the reaction product, which will lead to a more solidification of the AAC. We have dry intensities from 400 to 700, where we have the resistance from 1.3 to 8.5 as well. And so you can see here, as you can see on the tables, here, the optimum conditions for concrete needs to have 1.3 megapascal. So in that cell, when we look at the thermal conductivity levels, we see that we have low values, proving that they are quite resistant to fires. And when we look at the dryness and deconstruction, as a result, we see that after the water that is absorbed is removed from the AAC materials, this happens. And in a sense, when we look at the AAC, we see that the contraction happens after special conditions. However, solidification through air is a factor that actually intensifies this contraction. Apart from that, durability is very important for AACs as well. The more porosity it has, the more the capacity to inlet gas and liquids. But we should be careful about this, as I pointed out. And the thermal conductivity, as I said, has to do with the intensity and humidity and components of the material. When we look at the super white cement used for AAC, as you know, it's Portland cement. And normally, Portland cement is used for AAC production, but we wanted to also use super white cement from Çimsa to see if we could somehow remove the disadvantages or mitigate the disadvantages to prove additional support for its properties. As you can see here, the first differences between Portland cement and white cement. And here is the 60 minutes is the difference between the starting time, and we know that 60 minutes is quite an important duration for our sector. We see that white cement is actually more resistant. So we, in our study, replaced Portland cement with white cement, but we kept the ratios constant. So we can see here various applications. First, we tried with 100% Portland cement and 100% white cement products. We have premium curation periods here, preliminary curation. So we have 2.5, 3 hours difference here. When we use the amount of white cement used, as long as we don't fall below 60%. So when we have 100%, 90%, or 80% white cement, we see that we have quite low curation periods. And trying to determine these, of course, we try to keep a standard for properties of the product so that we have a similar comparing and contrasting opportunities. And when we look at the following tables as well for cutting strength in that sense, and with different levels of solidification. This is a factor also emphasizing the relation between the white cement and a standard Portland cement. And we see that there is a resistance when using white cement. And see that, of course, when we see from the screens and the values that we can reduce the amount of cement overall up to 20% while using super white cement as well. As I told you, to vermolite phase was important for us due to porosity and other properties. And we see here in the tables the comparisons between standard cement to white cement in the values of factor A and pressure resistance, as well as dry intensity in that sense. When we look at this study, we see that white cement used for AAC was yielding different results. So we wanted to compare and contrast this when we use white cement for a basis for AAC. We said the preliminary creation period was reduced around 30%. And reduction of the cement, amount of cement overall as to 10%. And the resistance and thermal conductivity parameters were preserved. And the whiteness of the product was increased around 30% as well when using white cement. So together with the reduction in the period for preliminary creation, we have increased factors and results for environmental factors as well as emissions. And apart from all that, so as a result of all of that, preferring a white cement instead of Portland cement for AAC production seems to be a very advantageous and lively alternative. Thank you very much for your interest. Well, thank you very much. It's a really interesting perspective as well, because a normal standard cement is the only thing that we think of using for AAC production. But with apparently you have received or obtained very impressive results with the utilization of white cement for AAC production. And these are also in a period where sustainability is a focus, are very, very impressive. Thank you very much. So in light of all our presentations and very valuable information by our speakers, we have reached the end of our webinar on Precast. Thank you very much for your interest, and you can reach us always from our website as well.